Okay, so I'm going to open the new version of Drawbox.h and we can take a look. So here, obviously, the code has changed significantly. The object uses this primitive line to draw individual line segments. So basically, when we use our mouse clicks and mouse drag events to arrange these line segments, the new instance of this class is created and inserted in a dynamic container of these types of objects. So, of course, it's quite obvious that we're using two-dimensional coordinates for our segments. It also saves the color. Constructor for this class is taking a set of coordinates and the color, and uses initializer list to populate all of these data members of primitive line with the specified parameters. Of course, parameters are generated by us when we drag the mouse around the screen. And primitive line decides that it wants to have its own draw function. So here we're trying to ask Fluid what is the previous color or current color used by the pen to draw the lines and other primitives, and we save it as an original color. So FL color is one of the functions of Fulltext library. Then we call FL color and change the color to our own, right? So this is our own, and we update that, and then the line is drawn in window coordinates, but that's okay because we're working within the coordinates of our box, which in itself has coordinates relative to the window, but typically sometimes these widgets using their own coordinates, using their top left corner as 0, 0 location. Here it's not like that. The coordinates are uniform around the entire window. So we use the line to draw the line. I don't think it's diagonal line. It was probably a result of copy and paste. We can remove this little thing. So we draw the line, and then we restore the original color. So this is the protocol to use a customized color to retrieve the current color and then restore it back to the same color that it was before we were invoked. Now there is also a function built into primitive line that allows us to update coordinates. So basically my understanding is that if I run this program one more time, okay, and so now once we press the mouse down, like click, okay, the x1 and y1 coordinate, the initial coordinate of the line, is calculated. Okay, so it's calculated like this, and if I press it down and start dragging it, this is dynamic coordinate. So this is why we need to be able to make this update. You see how even when I step outside of the window, it still follows my mouse, right? So here, this update is happening on every mouse movement right now with my left hand button of my mouse pressed down. So I'm dragging it around the screen. And when I release the mouse, the update of x2 and y2 coordinate stops, and now this line remembers its set of coordinates and then adds itself to the vector of lines that we have here. Then the user clicks again, and then the new line can be then drawn. Okay, so primitive line is designed to capture information that is happening during the creation of the line, and also to maintain the visibility of the line by providing the draw function, which knows how to communicate with full-text library primitive drawing functions right here, right? So we have this arrangement. So now let's continue on to the Drawbox. So this is our helper object, which is the type of object that represents each line. Now here's the newly redesigned Drawbox. So this Drawbox continues to derive itself from FLBox, the same arrangement, of course. And you see this little flicker of the border when we enter and exit. Is kind of just demonstration of the mouse sensitivity in our application. And so we have this border color that we maintain. Now we also have a set of integers right here, which are required by Drawbox to create push. The initial mouse button push down, because look, if I click and push the mouse down, and if I release without dragging the mouse, nothing gets created, because it's just like clicking. Clicking is not creation of this primitive. But if I click down and then start moving, then the line gets created. The actual object, primitive line object, is created. So this initial click, this initial push down event of the mouse is stored temporarily in these two coordinates inside the Drawbox. That's just the internal handling of mouse clicks. So when we do create these primitive lines, we organize a vector of these primitives, and we store primitive lines in a vector. So vector is extremely convenient dynamic container. So we just say that we want to have a container of these line objects that we just examined at the top of this file. There's also some kind of helper value that we create here. Simply define it as -1. So we'll discover what this is and where it gets used. Now, so of course, as we added new data attributes to the list of attributes inside this more interesting version of this box, we have to update our constructor. So the constructor actually matches the constructor of FLBox, but the border color and these two push X and Y coordinates are set to predictable values. So we initialize color to blue, and use this this here as an illegal coordinate. So basically we say before the user actually clicks, just makes an actual click, we want to keep these coordinates to some kind of predictable value, which is not exactly the value that we expect from the user. So this is something recognizable. Very good. And this is again another example of constructor initializer list, and of course because this is all that we need to do in this constructor. By the way, delegating first line here is invoking constructor of the base class. So this is how you, if you want to make sure that you properly construct the base class, especially if it doesn't have a default constructor, we must use initializer list like this and just pass whatever parameters it's expecting from us. So now Drawbox, there is the updated version of the draw, okay, and now because it does various types of things, now it's more structured. So what I decided to do with the draw function of our custom drawing box is that, of course, we are obligated to make this call first. We need to tell FLBox that we're just about, like, basically starting this protocol of drawing things. And this is fine. We just make a call like this. Just don't forget to do this, otherwise there could be some consequences, and you can research full-text documentation online to what may be the reason, but this is very common type of thing. Then what we say is that with every instance of the draw, wherever this function is called, we want to remove the previous drawing. So I have this draw clear, okay, so this somehow clears the previous drawing. Then I say let's draw the border, and then we draw the actual primitives, and these primitives of course are our primitive lines. So far this is the only type of primitive that we have. So these are the steps, the stages of the draw. Base class, clear, make a border, and then do the primitives. So the primitives, we already observed how primitives are drawn, right? So we have our primitive line. It has the draw, so it creates a line of a specific color. So here we return back to draw primitives, this stage of the draw. And here we just create a loop, go through each instance of each element stored in our vector of primitives, these lines, and we just tell them to draw themselves. So this is how the lines are drawn, and this is the last stage. Draw border. Of course, what we do is that we maintain some sort of border color. Okay, so we'll see how this gets updated, but initially it's being set to blue. I think our constructor initialize it with right here, yeah, FL blue, the one of the constants in full-text library specifying the color. Okay, so so we select this custom color, and here I specify basically the border is drawn as 4 line segments, and so I call FL line 4 times, and then we restore the original color, which is initially retrieved as a current color, and I mark the corners, the vertices here, A, B, C, D, this order. And these are, if you want to exercise, it's just pure geometry. I just compute coordinates of each vertices of each vertex, and say segment AB, BD, CD, and AC. There is actually a rectangle primitive that I could draw simply by specifying the top left corner and width and height of the rectangle. But I just, so far, I didn't want to throw in other types of primitive drawing functions, just stick to the line. And it's kind of interesting exercise to be able to sort of locate the correct coordinates and make sure it's sort of like a little bit of a testing of the platform as well, so that we figure out what are the coordinates and we draw segments in order: AB, BD, CD, and AC. So these are supposedly all of these. And what we do with the clear task. So first we clear, then we do the border, and then we do the primitives. They do appear in opposite order in our code, but doesn't matter. So again, we retrieve the original color, which is sort of like a background color for the drawing, and preserve it. But what we want to do, we want to fill this area with the actual FL background color. So this kind of grayish shade right here is background color that we use uniformly. So I just say, okay, let's switch to this color. And now we specify again this rectangle, but this time FL rect F is filled rectangle, right? Filled rectangle call. So we say which color we want, and then we fill the rectangle of this of this dimension. And notice that for X and Y we use what we have, but then we subtract one from the width. And by the way, in 2D graphics, and as we start doing these 2D graphics, It's important to know that all of these coordinates, all the width and heights and all that, are in pixels. So these are just straightforward pixels. So this is why, because I don't want to the clear to disturb the border, I keep this filled rectangle within the border. So this is why we subtract 1 pixel from the actual from the second coordinate. So you can, so that's the reason why it appears as -1 deducted from the width, from the current width and height. Okay, and of course then we restore the original color. So this is what we have done to reorganize the drawing of our FL box, right? So these are all the stages that the new stages that we handle, and we handle all these parts that we need to draw. And since we clear everything, you can see that with every redraw, every time like we move around like this, or like when we minimize and maximize the window, every time this draw is invoked, all of this happens. Like every segment is redrawn, everything is redone.